All right, so here we go. We are on past the kind of final touches, I guess you could say, and on to looking at the simulation. So here we are in the Fusion 360 simulation. Let's go ahead and talk about how the simulation is set up. So number one, I go into loads and I set up gravity and forces. And again, I'm not going to go too deep into detail here. I'm just going to talk about what the settings are. I'm going to later be doing a Fusion 360 simulation course, and so you're going to have to take that for more concepts. So I did a 20-pound force here, 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 and here. Because we were looking at about 80 pounds combined. So each time you click on a face here, so I clicked on 1, 2, 3, 4 faces. Every time you click on a face, it's going to automatically put that force on each of the faces. So here we have 20, 40, 60, 80, right? Kind of equally balanced. And I'm going to say the battery is about 65 pounds, but let's just throw it to 70 with the box and all the, the steel hold downs and the battery cables and all that stuff that's kind of hanging on it. Let's just call it 80 pounds. So why didn't I just have the box on here? And I removed the box through the simplify menu. Again, in the Fusion 360 simulation course, I'll go through that. So why didn't I just do the box? Well, the reason why I didn't just do the box is that it will kind of make that like a rigid, it'll make that kind of stiffen this up with the plastic. There are other ways to do it, but you're better off just saying that all the weight is here. Another thing that you can do is you can have some beams here or something, or you could design something in here and put 80 pounds. But this is pretty close. This is pretty close to what it would actually be. Obviously, you'd have 20 pounds here, 20 pounds here, 20 pounds here, and 20 pounds here. It would kind of evenly distribute out because the battery is kind of evenly weighted. It's got liquid on the inside. It's pretty evenly distributed throughout the entire casing of the battery. So this is pretty simple way of looking at it. So with 20, 20, 20, as you see, these are the forces that are going down. So total of 80 pounds, and I put the constraints on the inside of these holes, which is what is holding up the battery cradle, right? That's where it's bolted in, and then I have it generate um, all the contacts. So we have contact here, contact here, contact here, contact here, contact back here, between this and this piece and this piece and this piece, and then these are contacting each other, right? And as you can see, this is displacement, but the main thing that we're going to be looking for is safety factor. And as you can see, min and max, and this is SF, safety factor. So what this means is that this is how many times, it's not exactly linear as far as how force is concerned, but how you can kind of think about it is that you would have to have this number more stress. And stress is again not a linear component, but um, it depends on the type of load case, and we're not going to get into that. So it's not actually linear. So that doesn't mean that because you have a safety factor of 15, that if you apply 15 times more force or weight, that it would survive that. That's not necessarily true. Um, it is not a linear correlation, but it would survive 15 times more stress, which again is not directly related to force, linearly at least. It is related to force, but not linearly. So standard is, you see here probably in the yellow. I'd probably go not. You don't necessarily need to go into the green. So 3 is okay. And if cost is a serious issue, then you can keep it at 3. Right now we're 15 plus, and usually when it says 15, it's actually more than 15. It just won't say anything past 15 because generally 15 is like way higher than you would ever need to do most applications that you would use in a simulator like this, in a simulation tool like this. So this is plenty enough. Obviously, if I had 3, safety factor of 3, I would say probably also then it would be okay, right? But then the reason why we want to have a decent safety factor on this is that if we have some sort of bouncing or stuff, which this truck is going to go through, so what will happen is as the battery goes up and then comes back down, it may have additional acceleration and then a sudden stop. So if all of a sudden there's a sudden bounce and the truck, goes up slightly and then releases all the weight and then comes down very quickly, we want to be able to take that kind of force, right? If gravity adds, if a little bit of extra not acceleration, but the acceleration will add a little bit more force to it, and kind of come down quickly and add a little bit of an impulse. We want this guy to be able to take it, flex a little bit, and then be able to absorb it and not take a whole bunch of, and not be able to deform pretty much permanently. So, and then we can go here and look at the stresses. And so as you see, we have quite a bit of stress around the bolts. That's actually looks like where most of the stress is. So if we go up here, yeah, so you can see these are the highest stress points. So you can see we have a lot of stress up here where a lot of the holding strength is. And then we have some stress here, which this is not as supported. See, this here is basically completely supported here. So this is not really this is not really a cantilevered member because you're all supported in here. While this guy is unsupported, as you can see, is cantilevering out here with the only supporting point starting here, right? And then this supported here. So quite a bit here. And then you can see also where the two join, there's also a lot of stress there. So generally, whenever you have a point where there's a pretty sharp angle, you'll have some stress concentration. So here you can see where these two join, we have some stress concentration there. And then there would be a weld on the inside here, right where that's at. So this would probably be all welded in here. So that's similar to how you would actually see it in real life. And obviously most of the stresses are going to be inside the bolts because that's what holds it. And that's where basically all the holding strength is coming from. And then here, yeah, so you can see this is where most of the strain and most of the stress is coming from. So, and then we can look at reaction forces. So here we have in pounds. So 15 pounds reaction force here to hold it up. So, yep. And then contact pressure. Obviously these doesn't matter. So here basically we need some contact pressure here. So there's like some bending here at all the joints. And these are all the contacts basically. These are all the system put contacts because these are all separate pieces. This one and this one's separate piece. This one and this one's separate piece. So where they're all joined, you'll see a contact pressure. But here we don't really care much about that because of we have welded these together. So there's not necessarily a contact pressure because they're not necessarily in contact. They are joined because they're welded, right? So they're not necessarily contacts. But here it's just saying contact pressure, right? But in actuality, this thing can be thought of as one piece because it's all welded together pretty much. So you can think of this as one piece, so there's not necessarily contact pressure, except for this is contacting the back wall of the truck, right? But the back wall is not modeled, so yeah. So that also technically means that this would probably not deform that much because you're basically pressing this against to the wall. So there's some friction there and some support keeping it from deforming. But as you can see, we have really, really, really good performance here. No problem here. We should be good to go. And another cool thing to look at is the displacement in inches. So here you can see that obviously the highest displacement is right here at the cantilevered edge. We're going to get about 0.1, about 1,000th, 0.0013. So 1.3 thousandths of an inch deflection, which is pretty low. So this system is very, very strong, and I think it will be great. Also, another thing that we're missing, obviously, is in the actual thing, I'll probably put some expanded steel down here, or maybe even a sheet of something, a sheet of metal, a small, 1/8 inch sheet or something that goes across here just to kind of support the bottom of the plastic, or even maybe a piece of plastic on the bottom, something super thin, preferably something that won't bend as much. So maybe a piece of plastic, maybe a piece of metal or something here. that will as also help support this area. So that'll support this area a little bit, as well as support the middle section where the battery's sitting, so the box doesn't actually bow a little bit. So I'll just put a little piece of 1/8 inch steel in here, and then we should be good to go. And that should also strengthen this up a little bit. It'll probably be welded in, so I'll weld it in and then weld it in from the bottom. So come in here from the bottom and then weld it in right here, right here, right here, right here. And so this would kind of create a mesh that will support this. So I'll either do that or do some expanded metal and then help with that as well. But obviously that's not a super structural component. It's just going to make this even better. So if this was going to pass, that version would definitely pass. So I think that piece of sheet here will make this even better and strengthen this area up a little bit, because this is like basically the weakest section right here, and strengthening this up would be pretty good. And then also another thing that you can do is you can put a beam across the bottom here, right? You can put a beam across the bottom, and then that would also help as well. And another thing obviously is we're going to have the bolts go through here, and then a flat bar. So the flat bar is also going to help have some of the weight back over here as well as over here, because we're going to have the bar up across the battery. So there's a couple things that would even strengthen this guy even more. So right now, this cradle looks good, and we are ready to. It would be fine to manufacture. So we'll see if anything else comes up with that I want to add in their lesson to. We'll do that. Otherwise, we'll go ahead and construct it, and the client will get the material, and then I'll build it, and then we'll see it in action. All right, that's it for this lecture. I'll see you guys in the next one. Take it easy.